Let's solve this problem. Light is incident on two slits that are separated by 0.2 millimeter. So D is 0.2 millimeter, which is 0.2 multiplied 10 to the power negative 3 meters. L is equal to 1 meter because the problem says that the screen is 1 meter from slits. It's asking to determine the wavelength. So lambda is what we want to find. Now from the problem itself, from the diagram, we can find the value of y, which is a position of the bright fringe, which is 7.5 millimeter, and again we convert that into meters. Because it's asking for lambda, so we use the formula y equal to m lambda L over d, and we rearrange it for lambda. And then we substitute the value of y and d. And the value of m, if we look at the diagram, we can see that it is the third bright fringe, which is labeled in the diagram. And the value of L is 1, so we multiply by 1, and we get the value of lambda as 500 nanometer. We can see that the lambda value which you get by calculation is 5 into 10 to the power negative 7, which we are converting into nanometer by moving the decimal. So if we move 2 decimal to the right, the power will change to negative 9. Let's see one more problem, how to solve this one. The figure shows the interference pattern produced when light of wavelength 500 nanometer. So we convert that into meters. Fringe A is equally distant from each slit. That means fringe A is the center fringe. It's the center bright fringe. By what distance is fringe B closer to one slit than the other? So here it is not clear what they are asking. So you have to think and then get to the answer and know what actually the problem is asking for, as it's not a direct problem. So we look at the diagram for the slits. We can see that B will have, at point B, the light which travels to point B will have path difference because they don't travel the same distance. So again we read the question, by what distance is fringe B closer to one slit than the other? So it's clear from the diagram that B is closer to one of the slits and far from the other slit. So they want us to find the path difference. And the formula for path difference is d sine theta or m lambda, because it's a bright fringe. So because theta value is not given, but we know the value of lambda and we also know the value of m from the diagram. So we will use path difference equal to m lambda. M from the diagram we can count and we can see that it is 2, and substitute the value of lambda, we get the value of the path difference as 1000 nanometer.